Okay, so, well, when you have infinite time. So the equation of a line in Cartesian form, the equation of a line is ax plus by equals c. In parametric form, which we just learned, the equation of a line is r is equal to p, some position vector, plus t d, where t is a parameter and d is the direction vector. And in vector form, look, well, you didn't even have to wait till tomorrow. R dot n is equal to capital D. Okay, so what we're going to do is just basically go through converting from form to form to form, or form to form.
What is E?
We'll get there. Number one. Okay, so parametric form to Cartesian or vector form. Let vector r equal xy as a column vector, which is equal to -2, 1. This is just an example pulled out of, don't go looking where did you get it. It's just an example. Okay, so this is the parametric form. Of the equation of some line passing through the point -2 with the slope of 3 units. Right, but that doesn't really matter, right? It's not like, oh, did that come from somewhere? No, no, this is just an example, right? Here's a line in parametric form. Let us see if we can change it to Cartesian form and vector form, okay? So what are we going to say about x? What's x equal to? -2 plus 5t. Almost drew that as a t. Okay, and what's y equal to? 1 plus 3t. There's lag in here. So, what's t equal to from the x equation? X plus 2 over 5, right? But what's t equal to here?
Y minus 1.
Well, if t is equal to this and t is equal to that, what can we say about this and that? They are equal to each other. So if we do this, what are we going to end up with? How many variables do you now see? There are 2, so we're going to get the Cartesian form out of this, right? Because we got rid of the t's. So we started with parametric form, right? We solved each equation. We isolated, got the x, we got an expression for x, expression for y. Solved those both for t. Set the t's equal to each other, right? Which now gives us the chance to do a little mathemagic here. So 3. All right, which gives us what? 3x plus 6 equals 5y minus 5, which gives us, in Cartesian form, what?
3x minus 5.
Plus 11. No.
Minus 11.
Okay, so there's your Cartesian form. 3x minus 5y equals -11. Does not revolve around a point on the line, right, which we have. So in parametric form, we have a point and we have a direction. And we can use that to calculate all points in terms of some parameter t. Here is Cartesian form. So this is Cartesian, right? Cartesian. Named after who?
Cartesian.
Cartesia. It's a country.
Developed. Okay, that was good. Wrong, but good.
Wait, what do you say?
Okay, so you said it's Cartesia. It comes from the country of Cartesia. Where does Cartesian come from?
India.
Not everything comes from India. Some guy named René Descartes.
Now, how does that translate to the
We got cards.
And now, watch, as we go from Cartesian form to vector form. Okay? Right? Get this, watch this. X, Y. Now I want to dot it together, right? So dot. So how do I end up with 3x? Put a 3 there. How do I end up with minus 5y? Put a minus 5 there. Right? When you dot these together, it becomes 3x minus 5y. But that's got to be equal to something. There's your vector form. Oh my God, that's it, right? I mean, Cartesian to vector. Like, how much work do you do?
That's genius.
I expected more.
Yeah, I know, eh?
I don't want it more.
It had to be harder than that.
So you just put extra.
I thought this was IB.
That's coordinate of x under that, and there's coordinate of y under that, and equals the constant.
Amazing, yes?
What are you, workers IB?
Wait. It gets better. Well, maybe, I don't know.
It gets worse.
Vector to.
It can't get better. It's too good to be true.
What's the slope of this line?
3/5.
3 over 5, right?
Oh my God.
What's the slope of this line?
3 over -5.
Oh, please. Ruin it. You just couldn't keep it closed.
Oh my God, Jacob.
Back up. You, no noise. What's the slope of this line? 3 over 5.
Just Jacob, guys.
What's the slope of this line? Negative 5 over 3. How are those related? They're perpendicular. This is called the normal vector. It's perpendicular. That's the n in r dot n equals d, right? Okay, moving on. You guys are lucky. I've been through this once before. I'm actually starting to understand some of it. So.
Are you saying?
Oh, last year it was just sort of a toss-up. Let me tell you.
What?
Okay,
Worse enough.
so let's do this in general then, right? So now instead of a particular vector, we have a general vector, hk plus t times ab. So what's x equal to?
Oh, that's an A.
Okay, or ta, what's y equal to?
A plus TB.
tb. What do we do with these? We solve them for t. What's t equal to?
X minus H over K.
What's t equal to?
Y minus K over B.
What do we do with these two?
Solve
You make them equal.
Set them equal to each other. X minus h over a is equal to y minus k over b. So
X, B minus
b times x minus h. Take your time. Don't rush. It doesn't hurt to show a few stats once in a while, right?
It
You
hurts
guys are
to not
too.
show steps, though.
Yeah.
I think I realized that.
Well, gotta make it hurt, right?
last year or the.
Last year I got 90 somehow.
Yeah, but then when you didn't show them, it cost a couple of marks off of 100. Now it's starting to cost major marks. So.
Yeah. So.
Okay, now what do we do with this?
We have to.
Move them all to the left side.
No, move it into Cartesian form.
Don't.
So that's bx minus ay and then
Bx minus ay equals
yeah.
minus ax.
bx minus ay equals the constant.
He said B.
How about this?
Oh, B.
B minus ay equals
BH minus AK.
yeah.
AK-47. X, Y, B. Oh, make it.
PH minus AK.
Mm-hmm.
Yeah, that one.
Oh, okay.
AK. Oh, minus.
Minus.
That makes sense. Oh my.
Yeah, because it's just a constant.
Okay, so bx minus ay, left side, is equal to bh minus, let me clean this up.
Yeah.
Okay, so the idea was get the x's and y's on one side, right? So get it in the form. What do we need the form, right? We need the form to be ax plus by equals c. Well, ax, all right, so it's bx minus ay. But same idea, right? Something times x plus something times y equals some constant. This is really just numbers, right? A, b, h, and k are just numbers. Okay? So xy, b minus a, bx minus ay is equal to bh minus ak. And of course, you know what?
No, I don't know what.
I know. That AB is perpendicular to B negative A. Gives you a much faster way of getting there, right? And that n, the normal vector, is equal to B negative A, right? It's called the perpendicular to normal vector. So perpendicular, or normal. It's the normal vector.
That's our out.
Okay. Giving you r dot n equals d, right?
D.
D. Okay. Well, that's r, that's n, that's d.
Do we have a normal vector for
Knowing this, you got a little copy, Dan? Going from Cartesian or vector form, either one, right? They're very easy to go from one to the other, to parametric form. For example, 4x minus 3y is equal to, minus 15 equals 0, right? Nice general form equation, right? That's general form. General form is always equal to 0. We're going to change that to standard form because that's what we were working off of, which is 4x minus 3y equals 15. Okay, so that's our Cartesian form, right? ax plus by equals c. Yeah, good? Okay, so change that to vector form. xy
Equals 15.
Okay. Wow, Cartesian to vector, that's kind of rough, but it's doable. Okay. Okay, so that's vector form, right? R dot n. Okay. For parametric form, just B, I guess B. B for parametric form. What's parametric form?
R plus TD. Oh, wait, P.
Okay, so to get into parametric form, R plus 2E, we need a point P, right, and a direction D. We need a point P and direction or slope D.
No, I'm only hungry because we were talking about rising social.
Okay, so if we want to go to parametric form, you need a point and a slope, right? If we write the equation in slope-intercept form,
Oh, yeah, so for what?
then we'll get a point and we'll get a slope. If we write the equation,
Going backwards is a lot harder.
we will get a point. Which point will we get?
Someone else. Yeah. I'm just gonna go to shop and buy some.
What point do we get in slope-intercept form? The y-intercept, right? Slope y-intercept form. Whoops. The point we'll get is the y-intercept. And the slope is the slope. Right. Okay, so let's do that. So, okay, what do we got? We got 4x minus 3y minus 15 equals 0. 4x minus 3y minus 15 equals 0. So we're going to get 3y is equal to 4x minus 15, right? For algebra, degree, move the 3y over. So y is equal to 4/3 x minus 5. What's the point?
0 minus 5.
The point is to turn it into parametric. Oh, sorry.
Yeah, I see
Point
what
here. I did. What's the slope? 4/3. So r is equal to p. What's the point?
0 negative 5.
Plus t times the slope.
3, 4.
3, 4.
Jacob,
Yay!
Jacob,
Look at that. And so tomorrow you can just work on this. So you got no homework for tonight, right? So tomorrow it'll just be work period on equation of a line, questions in the thingamaboober.